So we're back, finally got the thing working here. All right, first thing I want you guys to notice, if you haven't been paying attention to it, is that you have your big homework set from chapter 3 and 4 is due by Friday, because Monday we're having our test. So I'm actually going to look at a couple of those questions right now, and then we're going to finish up our section 4.6. So let's go ahead and get started on this. So let me kind of darken down the brightness here so you guys can see this. Auto-focusing it. All right. So the questions I got from you guys is number 1. You want me to do number 1, which is always discouraging, but we'll look at number 1 then. Find the following point. Which of the following points are on the graph of f of x equals 2x squared plus 5x? To check to see if a particular point is on a graph, you're plotting them. This is x, this is y, this is x, this is y, this is x, and this is y. What's the x coordinate in the first one? 0. So if I plug it, remember y is the function. So if I plug in 0 in for x, that's going to be 2 times 0 squared plus 5 times 0. That's not hard math. What kind of y coordinate am I going to get? 0 squared is 0, times 2 is still 0, 5 times 0 is 0, and 0 plus 0 is 0. So this point is a check. What about number 2? X is 1. So I can do f of 1, and I'll zoom in and then kind of focus it up a little bit. F of 1, this would be 2 times 1 squared plus 5 times 1. 1 squared is 1 times 2 is 2, 5 times 1 is 5. 2 plus 5 is 7. Did they have a y coordinate 7? Then the second point works. What about the third point? What's f of 2? That's 2 times 2 squared plus 5 times 2. 2 squared is 4 times 2 is 8. 5 times 2 is 10. What's 8 plus 10? 18. Did they have 18 here? No. So which one of these would have been my answer? Which ones work? 1 and 2? The answer is A. Does that make sense? The other question people had was number 2. Number 2 up front here. All right, 2. Do the piecewise function. F of x equals, I got 3 pieces. I got 2x minus 1 if x is less than or equal to negative 1. I got x if negative 1 is less than x, which is less than 1. And I got x squared plus 1 if x is greater than or equal to 1. They want me to calculate what is f of 3 plus f of 2. I'm sorry, f of negative 3 plus f of 2. Well, first off, we want to find what f of negative 3 is. X is negative 3. So which piece of my piecewise function am I going to use? X is negative 3. The last time I checked, negative 3 was less than 1, negative 1, less than negative 1, which means I plug it into this piece of the piecewise function, 2x minus 1. So this will be 2 times negative 3 minus 1. 2 times negative 3 is negative 6 minus 1 is negative 7. The other point is f of 2. X is 2. Is 2 less than negative 1, between negative 1 and 1, or bigger than 1? What's 2? Bigger than 1, which means I plug it into this piecewise function, x squared plus 1. So this becomes 2 squared plus 1. 2 squared is 4 plus 1 is 5. So I got for f of negative 3, I got negative 7. Plus for f of 2, I got 5. And what is negative 5 plus, negative 7 plus 5? Negative 2 is my answer. Did that make sense? You pick the piece of the piecewise function that you need for that particular x coordinate and plug it into it and add it up. All right, so the next one somebody wanted me to do was 5. Find and simplify the difference quotient. G of x plus h minus g of x all over h, with g of x being x squared, 2x squared plus 1. Well, remember, we're trying to find g of x plus h minus g of x all over h. If g of x is equal to 2x squared plus 1, what is g of x plus h equal to? According to the rules. I don't care what's inside that parentheses. Whatever is inside that parentheses, I'm going to replace x in the original f of x, or in this case, g of x function. So, as g of x is 2x squared plus 1, what is g of x plus h? 2 times x plus h squared plus 1. Does that make sense? plugging x plus h in for x. Now I'm going to replace it over here. So g of x plus h is this 2 times x plus h squared plus 1 minus g of x, which is 2x squared plus 1, all over h. Now, before I move on, I want you to notice the wonderful use of parentheses. Parentheses around the g of x plus h minus, most important, the parentheses around g of x. Does that make sense? If you go g of x, they gave that to me as 2x squared plus 1, but there's a big old negative in front of it. So I'm going to clean this up by distributing that negative and dropping this parentheses, 2 times x plus h squared plus 1 minus 2x squared minus 1, that negative distributes, all over h. But I got to clean up this x plus h quantity squared. How do I clean up an x plus h quantity squared? Got to FOIL it out because it's plus. Plus or minuses with a power, you have to FOIL them out. So this becomes equal to 2 times, this is x plus h times x plus h. Then when you FOIL it out, that's x squared plus 2xh plus h squared. And where I got that from is I'm taking x plus h squared times x plus h. And when I FOIL that out, I get x squared plus xh plus another xh plus h squared. And xh plus xh is at 2xh plus h squared. And that's what I got. Plus 1 minus 2x squared minus 1 all over h. Let's keep cleaning it up. That 2 is going to distribute. That's going to give me 2x squared plus 4xh plus 2h squared plus 1 minus 2x squared minus 1 all over h. The nice thing about this type of what we call the difference quotient is lots of stuff cancel themselves out. What cancels themselves out on this problem? 2x squared and the 2x squared, the plus 1 and the minus 1 cancel out. Does that make sense? You're left with 4xh plus 2h squared all over h. Sorry, I'm off the page there, but there you go. But what does this numerator have in common on it? They both terms have a what? An h. And the only way you can cancel with fractions is strict multiplication division. Since they both have an h in common, I can factor out the h. That leaves me with a 4x plus 2h divided by h. And now, strict multiplication division, what happens to my h's? Cancel out, and what's my solution? 4x plus 2h, and that's what I'm looking for. 4x plus 2h, answer's A. Does that make sense? All right. The next problem somebody had a question on was, let's see if I can find one. I want to do 2 of these, all right? I want to look at number 23, and I want to look at number 22. I'm actually going to do 23 before I do 22 because they're the circle problems. All right, here's the deal. Okay? Now, to find an equation of a circle, you got to have memorized the basic form, what we call the standard form of an equation of a circle. What's the standard form of an equation of a circle? X minus h quantity squared plus y minus k quantity squared equals r squared, where the center is the point hk and r stands for the radius. In this particular problem, number 23, and I'll go back and do 22 in a second, find the equation of a circle with the center at the point 4, negative 2, so they gave me the center point, which will be my hk. That's telling me h is equal to 4 and k equals negative 2. And it's passing through the point 1, 2. So they're giving me 4, negative 2, 1, 2, 3, 4, negative 2. Here's my center point, and I'm going through the point 1, 2. X is 1, y is 2. I'm going through this point. What is the distance between the center and the outside edge of a circle? What is that called? The radius. So all I need to find the radius is the distance. So r, which I'll use the distance formula, which is the square root of x2 minus x1 squared minus y2 minus y1 squared. That would be the square root of the difference between the center and the outside point. Difference in x. It's 4 minus 1 squared plus negative 2 minus 2 squared. And watch your signs on this one. What's 4 minus 1? 3. Square root of 3 squared. What is negative 2 minus 2? Negative 4 plus negative 4 squared. What's 3 squared? 9 plus, what's negative 4 quantity squared? What's negative 4 times negative 4? 16. 9 and 16 is square root of 25. What's the square root of 25? 5. Your radius is 5. So now all I got to do is plug it into my formula. Your h is 4, your k is negative 2. Watch your signs. This gives me x minus 4h squared plus y minus k is negative 2. We'll clean it up later. Squared equals the radius, which is 5 squared. So when I clean that up, I get x minus 4 squared plus, what's a negative and negative 2? That'll be y plus 2 squared equals 5 squared is 25. And there's my answer. X minus 4 squared plus y plus 2 squared equals 25, which is answer, which one? I believe the answer is E. Does that make sense? But in connection, that was the easier of the problems. 22 is a little bit harder because they gave you this. X squared plus y squared minus 10x minus 2y plus 50 equals 49. Your mission is to find the center and the radius, which means I want to convert this convoluted form into the form of x minus h squared plus y minus k squared equals r squared. Standard form of an equation of a circle, so I can read off the center and read off the radius. Now, what method do I have to use to actually convert the equation of a circle, x squared plus y squared minus 10x minus 2y plus 50 equals 49? What method? Well, true, but what's the method called? Complete the square. We're going to complete the square on this thing. So the first step on completing the square is get the x terms together, get the y terms together, and move the constant to the other side. So this is my equation. X squared plus y squared minus 10x minus 2y plus 50 equals 49. I'm going to first move the 50 to the other side, get my constant on the other side, and then I'm going to regroup over here with my x's, get all my x's together. That'll be x squared minus 10x, leave a little space, plus group my y's together. Y squared minus 2y, leave a little space, equals, and combining my like terms, what's 49 minus 50? Negative 1. How do you complete the square? You take what we call half the b term squared. This is my formula for completing the square. You take 1/2 what I call the b term, and you square it, and you add that to both sides. Add to both sides. My b term on my x's is what number? Sign goes with it. Comes from the quadratic formula. What's the b term? Negative 10. So I'm going to take half of negative 10, which is negative 5, squared is going to give me what number? 25. I'm going to add 25 to both sides. Now I got to complete the square on the y terms. My b term is negative 2. Half of negative 2 squared. Half of negative 2 is negative 1. Squared is 1. I'm going to add 1 to both sides. Now, your x's are going to factor perfectly. How does x squared minus 10x plus 25 factor? X minus 5 times x minus 5, otherwise known as x minus 5 squared. Plus in the middle, how does y squared minus 2y plus 1 going to factor? It factors perfectly, so how does it factor? Y minus 1 squared equals, add it up, negative 1 plus 25 plus 1, the minus 1 plus 1 cancels, equals 25. There is my equation. From that equation, you can automatically tell me what my center point is. But remember, inside the parentheses, you take the opposite. So with the x's, I see x minus 5. So what is your h coordinate for the center? Positive 5. And for the y coordinates, I see y minus 1. So what's the k coordinate for the center? Positive 1. The radius squared is the number on the other side, which is 25, making my radius equal to 5. So the center is the point 5, 1, and the radius is 5, making the answer which one? The answer is D. All right. The last couple, and then I'm going to go on to section 4.6. The other question folks had for me before class, because they were having some major computer issues on our videos and stuff, is, so it took me a while to get class started here, but the marketing department at Extension Cord Corporation was found that the certain extension cords are sold at price P per unit, then the revenue of the function P is given by the equation R equals negative 2P squared plus 3,800P. So P is the price per unit that they sell it, and R is the revenue, the amount of money we're going to bring into the company. What is the price that should be established in order to maximize revenue? Okay? What is the price? That's the question. What is the price? Well, first off, and here's the key word right here, maximize. What kind of equation is R equals negative 2P squared plus 3,800P? What kind of equation is that guy? It is a quadratic equation. And when you hear the words quadratic, or at least have a quadratic equation, they're talking about maximizing or minimizing. What are you always after? The vertex, right? And I can tell you more about this particular quadratic. What is the leading coefficient in front of the p squared? Negative 2. Negative 2 makes it an upside down parabola. If it's an upside down parabola, what kind of vertex am I going to have? It's a maximum. Do you guys remember the formula for the vertex of a quadratic? Well, it's the vertex is the point, we use the same symbols, HK. But h is equal to negative b over 2a, and the k coordinate is f of that negative b over 2a. So, negative b over 2a, this is a quadratic. You know, the old ax squared plus bx plus c, you know that's where the terms come from. So in this problem, we have a revenue equation. A is going to be negative 2, b is going to be 3,800. But what's c equal to, by the way? It's 0, because there is no constant term on this thing. I'm going to plug it into my formula and get my vertex to be equal to h is equal to negative b. Negative b is 3,800 over 2 times a, which is negative 2. Well, I can clean that up. That's negative 3,800 divided by 2 times negative 2 is negative 4. And negative 3,800 divided by a negative 4 is a positive, how much? 950. So h is equal to 950. The k coordinate is f of that k coordinate, 950. So that would be using my calculator and plugging 950 into my equation. Negative 2 times 950 squared, let's see, that's my p or my x coordinate, which stands for p, plus 3,800 times 950. So this is going to give me the k coordinate, which is 1,805,000. But now you got to understand what my vertex is. The vertex is the point 950, comma 1,805,000. But what does this represent? This is the H or X coordinate, but the X coordinate of my problem is P, which is your price, and the K coordinate is the revenue or the Y coordinate. So basically this is telling me I should set my price at $950 per unit or whatever, and I will bring into the company my maximum revenue would be $1,805,000. But the question is, what unit price should be established in order to maximize the revenue? What is it? $950. The answer is B. Does that make sense? So anytime you hear the word max or min, think of those quadratics and the formulas for the quadratics. Second to the last one is this one. And this was that variation stuff I did last week. A varies directly as B and indirectly inversely means the same thing, as the square of C. Let's stop there for a second. When we're talking about variations, you're talking about trying to create an equation. Something varies means something equals some arbitrary constant proportionality, we typically call it K, times some variables here. So when I say A varies directly, that means A equals varies directly. That means it's some constant, arbitrary constant proportionality K times as B times B. And indirectly means I'm going to divide by the square of C. You got to put this math into English. What is the square of C? Otherwise known as. The square of C is what? C squared. But that would be too difficult for them to write that. They have to write it in the proper Queen's Own English, C squared. So there it is. A equals K times B divided by C squared. Going from English to math. Remember, varies directly means equal K times and then just list off the rest of the variables. Directly, variables go on top. Indirectly or inversely, the variables go on the bottom. Okay? Now the next piece of the puzzle when you're doing variations is plug in your numbers. A is 2, B is 18, and C is 3. That's all that information is help you figure out what K is. So A is 2, so this tells me 2 equals K times B, which is 18, divided by 3 squared. Well, let's do some math here. This implies that 2 equals 18 times K divided by 9. Well, what's 18 divided by 9? 2. So 2 equals 2K. Divided by 2, that's awfully nice. What's K equal to? 1. Thus, therefore, A is equal to K, which is 1, times B divided by C squared. What's the question here is find A when B equals 6 and C equals 2. So A equals 1 times B equals 6, and C is equal to 2, but you're squaring the C. So I just plugged in my numbers here. We're supposed to, let me write that down. Find A when B equals 6 and C equals 2. So I plugged in for B, 6, C, 2. Let's clean it up. This means A is equal to 1 times 6 is 6, 2 squared is 4, but you can always reduce your fractions. What's 6 divided by 4? 3 halves. So what's my answer? D. Does that make sense? The last one is someone wanted a question on the free response problem. Now, I'm not going to do this one for you, but I'll help you set it up. Okay? Farmer Brown has 1,200 feet of fencing to create a rectangular pen. He would like to separate the pen into 4 areas, and I broke it up for you. 4 areas. What dimension will maximize the area, and what is the maximum area? So we've got the fence to be 1,200 feet of fencing. And we're going to put fencing here, 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 and here. I call that W variable. And I put the fencing here and here. So I have 4 pins within this big lot. So the first thing we do when we're trying to maximize something or others, we got to come up with the formula for this thing. Now, we want to maximize area. Well, what is the formula for area? And if you look at the picture, what kind of picture do I have here? One big picture of a rectangle. what is the formula for the rectangle? It's length times width, right? Problem is, it's too many variables. But I have something, because this is my objective equation. This is what I'm after. But my constraint, what I'm under is, the fact is we have 1,200 feet of fencing. I'm going to come up with an equation. That's another, what we call a constraint or a linking equation. Fencing here. Where am I putting fencing at? I'm putting fencing here on the bottom, here on the top. How much fencing did I put so far? 2 what? 2 L's, right, using my variables. Plus, where else am I putting fencing? Here, 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 and here. How many is that? 1, 2, 3, 4, 5 what? 5 W's. And that's all the places I'm putting fencing. That's equal to my fencing of 1,200. Does that make sense? Did I lose you guys anywhere? Now I'm going to solve this equation for L, because this is a linking equation. As 2L plus 5W equals 1,200, I'm going to subtract 5W from both sides. I get 2L is equal to 1,200 minus 5W. Now what have I got to do to solve for L? I'm going to divide by 2 on all terms. What I do to one side, I do to the other. What I do to one term, I do to all terms. Terms are separated by addition or subtraction. This gives me the equation L is equal to, what is 1,200 divided by 2? 600 minus 5/2 W. And I'm going to take that equation and plug it right in here for L. That's going to give me area is equal to L, which is 600 minus 5/2 W times W. Let's clean that up. Area is equal to, I'm going to distribute. This is 600 W minus 5/2 W times W is W squared. And what did this formula just turn into? What kind of problem? It's W squared. It's a quadratic. And they're talking about maximizing. So I'm going to rewrite it so you guys will be happy with my equation. Area equals 5/2 W squared plus 600 W. And they want you to maximize. It's a quadratic. So what am I looking for? The vertex. And I have a formula for calculating a vertex. The H, or in this case, the W coordinate would be the formula negative B over 2A. The K, or the area, would be F of that, or that negative B over 2A, and plug back into W. And if I need the length, I can go back once I get W and plug it back into this equation down here to get W. So what I'm telling you is, to maximize this thing, is you want to, honestly, you want to sit there and take this quadratic and find the vertex of it. And the H coordinate of your vertex is going to give you the W variable. Once you get W, you can plug it in here to get L, and then you can plug it back into the original equation to get what the area is. And don't forget your units. What's the units on this thing measured in? Feet. So length will be in feet, width will be in feet, but what would the area be in? Feet squared. Don't forget your units. All right, let's go back to the last section we got before our test, which is section 4.6. Section 4.6 is on inverse of functions. Inverse of functions and the horizontal line test. All right. First off, we have something called the horizontal line test. Quote, a function that f that passes the horizontal line test means that provided no horizontal line intersects the graph at more than one time. And when a function passes the horizontal line test, which means if you take a graph and you graph it, for example, I have like a cubic graph or something like this, is this thing going to pass the horizontal line test? Any horizontal line should intersect the graph at how many spots? One spot. This thing does pass the horizontal line test. However, if you look at, for example, a quadratic we were just playing with a few seconds ago, okay? Does the horizontal line pass, does this pass, a quadratic pass the horizontal line test? A horizontal line will intersect in more than one spot. Does not pass. This one passes. And a horizontal line should only intersect the graph at most one spot. Okay? One-to-one function. A function f of x is one-to-one if every element in the range corresponds to only element in the range, in the domain. Okay? This is the definition, the classic textbook definition of a one-to-one function. F of x is a one-to-one function if every element in the range corresponds to only one element in the domain. In other words, 1x corresponds to 1y. And nobody else can map to that y, that x can't map to anybody else. So 1x maps to 1y. When you were doing the horizontal line test on this stuff, the horizontal line test is a test for one-to-one. To make sure you have a one-to-one function. Only one-to-one functions pass the horizontal line test. In other words, quadratics are not one-to-one. Cubics, in this particular case, x cubed is a one-to-one function. Okay? Only one-to-one functions have passed the horizontal line test. So, here we go. Examples. Determine whether each of these functions is one-to-one. All right? X squared plus 2. If I want to check to see if something's one-to-one, what do I want to do? I want to graph it. Now we're using previous math section materials here. F of x is x squared plus 2. X squared is the shape of a parabola. What is plus 2 going to do for me? Shift it which way? Up 2 units. So take your standard quadratic parabola and shift it up 2 units. 1, 2, point here, and you get your standard parabola. So forth and so on. Is it one-to-one? That's my question. One-to-one question mark, horizontal line test. Does it pass the horizontal line test? No. So is it one-to-one? No, not one-to-one. But let's take a look at this guy. G of x equals x divided by x minus 2. Okay? Well, this is a little more elaborate type of graph, so let's just put that one on the old calculator just to make sure we get it right. So it is x divided by parentheses around your denominator, because I got multiple terms here, x minus 2. And I'm going to do a zoom standard, zoom 6, negative 10 by 10 screen, negative 10 by 10 screen, and I get this picture. And I'm going to kind of elaborate it right here. But you know, we can go into further details on this thing. This thing has a vertical asymptote. Where's the vertical asymptote at? 2. It's where the denominator equals 0. So x minus 2 equals 0. Add 2, x equals 2. Vertical asymptote. It also has a horizontal asymptote. What's the horizontal asymptote? Well, the degree of the top is 1. The degree of the bottom is 1. So what is the horizontal asymptote? The ratio of leading coefficients, 1 over 1, which is y equals 1. Okay? And you notice this graph actually does this. Goes through 0, 0, and then shoots straight down and goes here. I'm just making the classic elaborate graph on this guy, but here's my question. Is it one-to-one? Yes or no? Horizontal line test. Any horizontal line intersects the graph at only one spot. Does that make sense? And if any horizontal line intersects the graph at most one spot, then it's one-to-one. So is this one-to-one? The answer is yes. A one-to-one function. The reason why we're interested in these one-to-one functions is this. We want to find inverse functions. Now, just remind ourselves, what exactly is an inverse function? An inverse function is taking the x, which is your typically domain independent variable, and your y, your dependent variable and flipping positions. Basically making the dependent variable independent and making the independent variable dependent. It's turning the function inside out. And for a inverse to be a function, it first has to be a one-to-one function, because you have a theorem. Only one-to-one functions have inverse functions. Only one-to-one functions have inverse functions. So here's your answer. If they're asking, find the inverse function if it exists, the first thing you got to do is check to make sure it's one-to-one. Because if the function is not one-to-one, it doesn't have an inverse function. It'll have an inverse, but it won't be a function. It'll violate the vertical line test when you switch the x and y coordinates, which means it doesn't have it won't be a function, and we don't care about things that are not functions. So only one-to-one functions have inverse functions. So here are my steps to actually find f inverse. First thing is you got to make sure your function that you're playing with, the original function, is one-to-one. Check the horizontal line test. Step 2, replace the function with y, because it just makes it easier. So I have y equals something in terms of x. And step 3, here is your big step on doing inverses. Switch the position of x and y. You're switching the independent dependent variables. Okay? You're going to get x is equal to something in terms of y. And here comes the hard part. The hard part is then you got to manipulate the equation and solve it for y. You're turning it inside out. And then the last thing is you replace y with the inverse notation. F with a little minus 1 means f inverse of x. And you've created the inverse function. So, turn page. Examples. Find the inverse of each of the following. All right. Here it is. 5 steps to glory here. So, step 1. I want to find the inverse function. What's the first thing I should do? S1 stands for step 1. We're going to graph it. What does f of x equals 5 plus x look like? What kind of equation is this, dude? It's a line. What's the y-intercept? 5. 1, 2, 3, 4, 5. What's my slope being a line? 1. Coefficient of the x is 1, so I'm going to rise 1, run 1. 1 over 1, 2 over 2, or down 1 over 1, down 1 over 9. And you can just connect the dots, and there's my graph. There's the line f of x or y equals x plus 5. Is it one-to-one? That's what you're really checking here. One-to-one, question mark. Any horizontal line intersects at only one spot, so the answer is yes. This thing has an inverse function. Step 2, replace function with y. That gives me y equals x plus 5. Step 3. Step 3 is the most important step there. This implies the inverse. Switch the x and y coordinates. So if I have y equals x plus 5, what is that going to give me? X is equal to y plus 5. Step 4, solve for y. So I have x equals y plus 5. Solving for y, I would subtract 5 from both sides. That's going to give me y is equal to x minus 5. And then step number 5, we're big into notation in mathematics, and you've got to give the proper notation. What was the original function called on this dude? What was its name? F of x. So this guy is going to be called, you found the inverse, f inverse. F with a little minus 1 of x equals the function x minus 5. And there's my answer. Take a look at number 2. K of x equals parentheses x minus 1 cubed. What does x minus 1 cubed look like? Well, what's your basic function? It's a cubit, which makes it a squiggly line. But what is that going through the origin there? What is a minus 1? Inside the parentheses, which way is it going to go? It's going to shift it which way? To the inside parentheses. Take the opposite. I see a minus 1, so I'm going to go to the right 1 unit. So when I graph this thing, right 1 unit, so it's a a squiggly line going through the origin, but shifted right 1 unit because of the -1 inside parentheses. Horizontal shift right 1 unit, so it looks something like this. Question, is it 1 to 1? Any horizontal line intersects the graph at how many spots? At most 1, actually intersects at only 1. So the answer is yes, it is 1 to 1. Always label your axis on this stuff. So there it is, the answer is yes. So we can move on to the next step. Step 2. Replace the function, this guy's called k of x equals x minus 1 cubed with y. So that's y equals x minus 1 cubed. Step 3, that's the most important and the inverse step. What am I going to do in step 3? Switch the x and y. What is that going to give me? X is equal to y minus 1 cubed. Step 4, I want you to solve for y. I have x equals y minus 1 cubed. What's your first move to get the y by himself? What gets rid of that cube? Cube root. Take the cube root of both sides. So I'm going to take the cube root of both sides. What I do to one side, I do to the other. The cube root and cube cancel. That gives me the cube root of x is equal to y minus 1. And remember, with odd roots, you don't have to do any kind of weird plus or minus thing here. You just take the cube root of both sides. Now I got to solve for y. What's my next move? Add 1. That gives me y is equal to the cube root of x plus 1. And then I go to, and I'll move this way, step number 5. I'm going to replace y with the inverse notation, but pay attention to what the function's name was originally. What was this guy called originally? K of x. So this is the answer, but we've got to give its proper due diligence. That is, what's this name? K inverse of x is equal to the cube root of x plus 1. And there's my inverse function. Does that make sense? Did I lose you anywhere? Well, let's keep going. This next problem is a problem that you see on lots of final exams. They love this problem. You'll see why in a second. The algebra is in great detail here. So this is a final exam question. I guarantee you it's going to be on your next final exam. So I'm going to draw my little line here so we don't get confused. There it is. G of x is equal to 2x minus 3 over x plus 1. The direction is going to be very straightforward. Find the inverse function if it exists. All right. The first thing to figure out if the inverse function exists is you got to make sure the function is 1 to 1. So this was pretty elaborate, so I'm going to draw this on the old calculator here. This is parentheses around your numerator. 2x minus 3 divided by parentheses x plus 1. And I'm going to just do a zoom standard on this graph. And I've got something similar to what I had before. Classic hyperbolic look there. So I'm going to draw this guy out. And I got a vertical asymptote over here at -1. And the graph does this. There's my graph. Now, is it 1 to 1? If you graph a horizontal line, how many points does it intersect? At most. Any horizontal line only intersects the graph at 1 point. Does that make sense? Which means 1 to 1 question mark? Yes. This is a 1 to 1 function. Step 2. Replace g of x with y. Y equals 2x minus 3 over x plus 1. Okay? Step 3. Step 3, and this is the big step, switch the x and y coordinates. What is that going to give you? X is equal to 2y minus 3 over y plus 1. Now here comes the hard part. Solve for y. How am I going to solve for y? I have x is equal to 2y minus 3 over y plus 1. What's your first move if you need to solve this thing for y? Multiply by y plus 1. Get rid of your fractions. I'm going to multiply both sides by y plus 1. What I do to one side, I do to the other. This will cancel, leaving me with x times y plus 1 equals 2y minus 3. What is my next step in terms of solving for y is I want to get rid of parentheses. So to get rid of my parentheses so I can juggle which terms I have. I'm trying to solve for y, so I'm trying to get all the y's by themselves. So the next step I'm going to do is distribute the x. I want to get rid of my parentheses. This gives me x times y plus 1 times x, which is x, equals 2y minus 3. Now I'm trying to solve for y. Keep your eye on the ball. So I'm going to get all my y's on one side and all my non-y terms on the other. So my next move, and I'm going to do this in two moves here, I'm going to subtract 2y from both sides. At the same time, I'm going to subtract minus x from both sides. The 2y minus 2y cancels, the x minus x cancels, but it groups together all my y's on one side. This gives me xy minus 2y equals, and on the other side I got minus x minus 3. I got all my y's on one side of the equation, the non-y terms, x's and constants on the other side. But here's the step that typically screws up a lot of students. Here it is right here. I had to solve for y. I've got y in multiple terms now because I had to distribute this mess. Because I have it in multiple terms, I can only solve for one term. The trick is to be able to solve for one y is you want to factor the y. Factor the y out. That turns into multiplication, but it gives you that one y term. That leaves me with y times, when I factor a y out of an xy, I'm left with x. Factor a y out of a minus 2y, I'm left with the minus 2, equals negative x minus 3. You have to factor out the y to get the one y term so you can solve for it. And what's your last move to solve for y? I'm going to divide both sides by x minus 2. Lots of algebra here, but we get the answer. Y is equal to negative x minus 3 over x minus 2. And one last step is this. This function was originally called what? G of x. So here is your step number 5. Give its proper name now. If this is called, if the function is called g of x, what's the inverse called? G, the little minus 1, inverse of x is equal to negative x minus 3 over x minus 2. There's my inverse function. Study this problem. This is a problem, again, they love to give on the final exam. So one, I'm going to hit you hard on this problem on your homework set as well as your test on finding the inverse of this dude, because I know they're going to give you this problem on the final exam. Okay? Take a look at problem number 4 here. H of x is equal to x squared plus 3. Find the inverse function, if it exists. So the first thing I want to do is I want to graph this guy. What does x squared plus 3 look like? X squared is the shape of a parabola. Plus 3 is going to shift it up 3 units. 1, 2, 3. And it's a parabola. Remember, only one-to-one functions have inverse functions. Is this thing one-to-one? Horizontal line intersects in more than one spot. The answer is no. Not one-to-one, hence no inverse function.
Would that be set the solution to that?
Or D and E does not exist, depending on how. Yes, it could be how they word it on Hawk system, but typically we would write D and E. Does not exist. The inverse function does not exist here. But there's a relation, inverse relation on this thing. You can switch x, y coordinates as you plot them, but the fact is you're looking for functional stuff, this thing's not going to be a function. So it doesn't have an inverse function. properties of the inverse and their functions is this. Look, when you're doing inverses, the big deal is this. You're switched at x and y coordinate. On a traditional function, x represents the domain of a function. Y represents the range of a function. So any function has a domain, all the x coordinates that work, and a range, all the y coordinates that work. But because when you switch the x and y coordinates, you have this kind of a property. Given a one-to-one function f, the inverse of f, denoted by f inverse, has this property. The domain of f of x is equal to the range of f inverse of x, and the domain of f inverse of x would be equal to the range of f of x. So basically, they switch. X goes to y and y goes to x. So, you give a problem like this. Given the one-to-one function, f of x equals the square root of x plus 1, you want to determine what the domain and range is of f inverse of x. Before we find the domain and range of f inverse of x, you don't actually have to go through and find f inverse of x. All you got to do is this. All right, so here's the deal. F of x is equal to the square root of x plus 1. There's my function. What is the domain and what is the range? What's the domain? Remember, when it comes to square roots or even roots, whatever is inside the parentheses, inside the radical, square root of x plus 1, must be greater than or equal to 0. Solving for x, subtracting 1 on both sides, I get x is greater than or equal to negative 1. We traditionally like this stuff in interval notation. What is x greater than or equal to negative 1 going to look like? Bracket negative 1 to infinity. That is my domain. What's the range? The range is the y coordinates. If you graph this function, put it on your calculator. It is a square root graph, which looks at the origin and bows out, but shifted to the left 1 unit, because inside the parentheses I got a plus 1. That's a horizontal shift. Left 1 unit, so it's negative 1, and it bows out like this, and it keeps on going up. If you don't believe me, you can also double check it on the old calculator. Square root of x plus 1, zoom 6 it. There it is. And notice it started at negative 1. I can zoom in on that. And there's my graph. Exactly what I drew. What is the range? Range is the only time I actually focus on the y-axis and the y-coordinates of the y-axis. The range is the y-coordinates, which I start at 0, because I hit 0, and then the graph continues to go up to infinity. So the y's would be greater than or equal to 0, which implies bracket 0 to infinity is the range. So the domain of your f function is negative 1 to infinity. The range of your f function is from 0 to infinity. Does that make sense? But here's the big deal. What is the domain of f inverse of x? And what is the range of f inverse of x? Knowing about inverses, domains and ranges switch positions. So what is the domain of f inverse of x? Is the range of f, which was what? 0 to infinity, including 0 to infinity. What is the range of f inverse of x? That would be the domain of f of x, which is bracket, including negative 1 to infinity. And that is my answer. Once I find the original domain and range, I just switch them to get the domain and range of the inverse, because that's switching of the x and y coordinates. Does that make sense? Because when you graph this thing, and I'll put it on my pretty picture here because it looks better than what I drew, where does the y coordinates at? This function, you first started with x is negative 1. Negative 1 plus 1 is 0. Square root of 0 is 0. So you actually hit that point right there. And then the graph just continues to go upward. So it's from 0 up. So the graph starts at 0, and we hit that point up. There's a typo on this one. So I fixed it on mine, you should fix it on yours. If the point 39 is on the graph of a one-to-one function, f of x, find the value of f inverse of 9. Okay, so in other words, what we're talking about here is this. The standard y equals f of x is the same thing, but when it comes to inverse notation, it's f inverse of y equals x. It just puts the function and makes the dependent variable independent and vice versa. So if y equals f of x, that's the same thing as f inverse of y equals x. Since I'm going through the point 39, that's telling me f of 3 is equal to 9. What does that imply? That f inverse of 9's got to be equal to? What's the answer? 3. And I think it was typed in an 8 there. That's a typo. It should be a 9. We're using this particular point 39. So if f of 3 equals 9, that means f inverse of 9 equals 3. If f of 1 equals 2, that means f inverse of 2 equals 1. Just writing it backwards. Does that make sense? All right. Take a look at this picture. Find the domain and range of f inverse of x. This is the graph of f of x. And I wanted to be a little more elaborate, so I put an open circle there, and I put a filled-in dot there. I want you to tell me the domain and range of f inverse. But what you really should do is start first and look at the picture and tell me the domain of f of x and what's the range of f of x. What's the definition of domain? The x-coordinates that work. What are the x-coordinates? Look at the x-axis on this thing and tell me the x-coordinates that work. Well, there's -1, there's -2. Do we include -2 or not? It's a filled-in dot that I put on mine. You couldn't really do that on the picture there. So what do I get? The domain is -2 to what? Nope, I stopped right there. What number is that? It's halfway between 1, 2, 3, 4, and 5. What number is between 4 and 5 right down the middle? 4.5, and because I put in an open circle, it's a parenthesis. Does that make sense? What is the range? The range, we look at the y-coordinates of my graph. Here's -1, here's -2, here's -3, 1, 2, 3, 4, 5. What's the range? Well, remember, you read the y-axis from lower to upper. What's the lowest number we hit? And it's a filled-in dot because we hit it. What number is that? -3 using the y-axis, and we go all the way up until we hit 5. But do I actually hit 5 with my graph because of that open circle? No, parenthesis there. So once I have that, I got for free this. What is the domain of f inverse of x? And what is the range of f inverse of x? Which is the question they asked me. But remember, when it comes to domains and ranges, f and f inverse switch positions because that's switching of the x and y. So the domain of f is the range of f inverse, and the domain of f is the range of f inverse. Does that make sense? Switch positions here. So the domain of f becomes what? The range of f inverse, bracket, -2 to 4.5, parenthesis. And the domain of f inverse of x becomes the range, is equal to the range of f of x, which is bracket 3, -3 to 5, parenthesis. Does that make sense? Switching positions. Well, I'm almost done with section 4.6. I got a little bit more to do, but I'll do this next time. However, I've already opened up chapter 5 for you guys, so I want you guys to go ahead and print out and watch the awesome pre-section videos on chapter 5.1 and 5.2. Go ahead and get ahead, because we'll cover that, because remember, on Friday, I'm going to finish up this homework set and do it all for you to prepare for your test on Monday. See you guys then.